Hi everybody, this is revision paper, practice paper 2019 for SA2 Probably 4 maths paper. Now we are going to go through, take a look at this question number 45 of section C. This is the solution explanation for this particular question. Now as we take a look at the question, you will see almost immediately you can recognize, okay, there's a diagram going on, there's a picture, and many of us will be able to one look at it and say, okay, there's something going on, there's a picture that repeats, looks like it's repeating, but it's at the same time was repeating is changing. And if you recognize that it's changing with a certain pattern, so it's a pattern question. So this is a clearly pattern. You have to recognize a pattern and solve the problem using a pattern that you can recognize. So the challenge for questions like that is, number one, recognize a pattern. Number two, after recognizing a pattern, come out with a strategy that can help you to get to the answer that is requesting you to find either the next pattern or when the next set of pattern appear. Okay, sounds a little confusing. Let's read the question first, then go rewind and read the question. So just now I said, okay, the method that you're likely to choose is solving a pattern. Okay, the diagrams below shows the sitting arrangement in a huge hall. There's arrangement 1, 2, and 3. The table over here, each table here has a number of people you can seat depending on the site that is being facing a possible chair that can be placed. Okay, then you can see a person. Okay, let's take a look at the arrangement. The question says here 1, 2, and 3. Arrangement 1, arrangement 2, and arrangement 3. So that's the pattern number that goes. There's one table for pattern arrangement 1, there's 2 tables for arrangement 2, 3 tables for arrangement 3. And I suppose you'll be able to understand that arrangement 4 will mean 4 tables, arrangement 5 will mean 5 tables, and on. Okay, so how many people, that's question A, how many people can be seated if 15 tables are joined together? That's the first question. The second question, B, how many tables at least should be joined together so that 116 people can be seated? Okay, you've got to be clear with the question. The first question asks for how many people can be seated. In this case, tables are given. The second question asks for how many tables. Okay, sorry, let me undo that. How many tables should be joined together? And in this case, the given one is 116 people to be seated. Okay, so that's the question that is given. Let's go with now the first step of I need to understand the pattern. Okay, so a few ways to solve this. When you say recognize the pattern, one of the easiest way is, okay, I recognize the pattern and I continue to draw the pattern out and then count as I draw the pattern out, or I recognize a number pattern and I list according to the pattern. Now let's try it out. These patterns may be quite challenging, so let me just zoom out a bit and do a bit of the writing. Okay, so I'm making some annotations at the side here. Okay, I'm going to try out a few ways of doing it. Oops. Okay, hope you can see it. Okay, a few methods. Okay, let's go with like arrangement 1, that's table 1. I can count 1, 2, 3, 4, 5. I got 5, and then arrangement 1, I've got 5 people. So this is table number, okay, and then people. Arrangement 2, I get 1, 2, 3, 4, 5, 6, 7, 8, and then arrangement 3, 8, 9, 10, 11. Okay, 11. Okay, so and then you see there's +3 and +3. If say I go according to my listing. Now I'm listing out according to the numbers. I go from 1 table, 2 table, 3, 4 tables, and I think that the pattern is +3, the next number is +3, I should get 14. Okay, let's check if it's 14 by drawing out the diagram. So let's say arrangement 4. Arrangement 4. 4 tables, 1, 2, 3, 4. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, indeed 14. And if I go on to the next one, 15 tables. Sorry, let me just erase 5. Okay, the next one is 5. That means I by +3, I should get 17. Okay, if I were to draw arrangement 5 out, then I'll get 1 table, 2, 3, 4, 5. Okay, so I will get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, pardon me, this drawing is not accurate. Let me try to draw this again, with greater clarity with the shapes. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, this is much clearer. So I've got 17. Now, you realize that, okay, if I'm really going to go to listing it one by one, 6 is 20, 7 is 23, 8 is 26. I go by the listing, okay, you realize that actually you would be able to get to the answer. But of course, the more you list, the higher chance you are not careful, you may make mistakes. Okay, and I can go down to 11, 36, 12, 39, 13, 42, 14, 45. Hold on, let me check. Oh, I see. That's what I mean. You're not careful, you just do count wrongly. It's +3, 35, 38, 41, 44, 15 is 47. Okay, so by right, you should get the answer of 47 people. Okay, so this first method of getting to the answer, very long and tedious, and high chance that you'll make a mistake by the listing if you're not careful, you counted wrongly, that's one possibility. And imagine if you're going to draw out all 15 tables. Okay, this will be quite a difficult, long time you're going to spend on drawing, and the chances of making mistakes really high. So there must be a different way to get to the answer, like a shortcut. That will mean I need to identify from the pattern a way that I can count like a shortcut. Okay, so meaning I find a counting method to regards to the pattern. So I found a shorter counting method to the pattern, like a formula. So what does it mean? Let's take a look. Okay, there are a few ways to doing this. That is really a number sense kind of idea. Okay, let's go back to the drawing and I show you the first way to get to a counting method that's shorter, okay, and you'll be able to get to the answer. Okay, let's say I use a highlighter to show you a set of patterns. Okay, let's say the first table, I ignore the first table and I look at the next tables. You realize it's a +3, +3. Okay, so then where can I find the plus 3 in the picture, in the pictures that I've drawn so far? So picture number 1, picture number 2, okay, not quite being able to see the plus 3, maybe this 3, okay, not very clear, okay, but how about here? Can you see in the next pattern? Here, there's a 3. Okay, then you look at the next pattern, say this one, table arrangement 4. Can you see the groups of 3? And then here, okay, now with this being written, can you identify a possible pattern? Okay, let's say the first table can sit 4 people. In between, you can sit 3 people. The next table, and the end, to the 2 ends, you can sit 4 people. Okay, nothing about the first table, just one table you need 5. Okay, and then second table, the second arrangement, 2 tables, you can sit 4 on one side and 4 on the other side. You've got the 5, one of the sides being joined together, so you got like 2 being taken away. Okay, right, then if you look at this one, I can have 4 people on the first table, 4 people on the last table, 3 people for each table that's being joined in the middle. Okay, so I have like 4 in the first, and then 4 in the last table, and in between all the tables sit 3 each. Okay, can you recognize the next pattern that comes? So you can do with the, you recognize the number, the changing, that's 3. Okay, and then can you fit it into a certain formula? So let's say I ignore, okay, I ignore the first and last table. Then I will have groups of 3. Okay, so let's say look at the fifth table. So I have 5 tables. Okay, I ignore the first and last table, that's why I minus 2 tables away. I've got 3 tables. They are grouped in 3s, groups of 3. Okay, groups of 3. Oops. Okay, so 3 tables, they are groups of 3. Can you see that? Okay, let me put that to the side here. Okay, so if I use this idea, so I have 3 times 3, that is 9 people can sit. 3 groups of 3, right? Then I plus the 4 in front and 4 at the back, so 9 plus 8. Is that 17? Okay, that works. This seems to work. So I have, let's say I have 5 tables. I minus the first and last table. I get 3 groups of 3. 3 times 3 give me 9. Then I must plus back the people who are sitting 4 and 4, so that's 8. Okay, let's try with table arrangement 4. Okay, so I have 4 tables. I minus the first and last table. I got 2 groups of 3. So 2 times 3 give me 6. 6 plus 8, is it 14? Yep, it is. Okay, this method seems to work. Okay, so table arrangement 2, that would be just 4 and 4, that's 8. So you got 8. 0 plus 8 is 8. Okay, let's try 15 then. Does it work this time? Okay, so if I have 15 tables then, I minus the first and last table, I got 13 groups of 3. 13 groups of 3, 13 times 3 give me 39. 39 plus the 8 from the first and the last table, is it 47? Ah, okay. So you got, yep, 47 people. So you got the first method. First shortcut counting method to get you to the answer. Let me just zoom in a bit to be able to see both sides. Okay. Can you see that? Right, so using this idea, take away the first table, take away the last table, groups of 3, then add the first table and last table, which is always 8, 4 in front and 4 at the back. Okay, using this idea, can I try to solve B? Okay, so let's say B, I have 116 people. So imagine if you're going to draw and least to 116. That's going to be really challenging, but of course during an exam time, if you're really stuck, you can't use the pattern idea to solve, then go with the drawing, go with the listing. Okay, now let's say I have 116 people for sitting. I can work backwards. So 116 people minus the first 4 and the last 4, that's minus 8, I get 108. Okay, so 108, right? That means I have 108 groups of 3. Okay, so 108 divided by 3. Let me just do my division here. 36. Okay, that means I will have 36 groups of 3. Now 36 groups of 3, that means I have 36 tables. They are seated by 3s, they are in the middle, right? So 36 tables plus they are in between, plus the one in front and one at the back, I will get 38 tables. Okay, so that's the answer for question B. Okay, so that's the shortcut for counting, finding a counting pattern, counting shortcut method for counting that gets me, that is found out from the pattern that I can recognize. Now there's definitely more than one way to get a counting shortcut for this. Alright, for example, let me just do a quick example. If you find that this is a bit heavy information by now, then I suggest, okay, you can take it from here and then you're good to go. So the key idea is to recognize a counting method shortcut for the pattern that you recognize. Now, another way of looking at this, another different counting method is still with, let's say I look at the patterns that is shown here. Okay, let me scroll it up. Okay, then another way of looking at this is, okay, I can look all these groups. Okay, and then if I put this last here, and I join it with the first table of 5. Okay, I can also look at this diagram as 5 plus 3 plus 3, right? So it's like 5 plus 3 plus 3 plus 3. That will give me also 14, right? And now if I look at the next one here, table arrangement 5. Let's say our first table is 5, so I count 1, 2, 3, 4, and 5. The next one will be, or I just take the last one and put it to 5. Okay, and then join it with the first table 5. Like I open up this side, put it to count this side. Let me use the highlighter. So it's that I count this side as with this side here. So the rest is groups of 3. So this is also a group of 3. So if I were to count it this way, I have 5 plus 3 plus 3 plus 3 plus 3. So 3 times 3, 3 times 4, 12, 12, also 17. Also 17. Can you see that? So this is a different counting shortcut. I can also do this method. So if I take a look at this and I use this method to solve, I can also do A. Okay, so if you look at this, I have table arrangement 5. I actually have 4 groups of 3. Table arrangement 4, I actually have 3 groups arrangement 3. So in other words, I'm looking at, let's say, 15 tables. I ignore the first table, I have 14. So 14 times 3 will give me 42 people who are sitting. And then 42 plus the 5 people from the first table, there will be 47. See? Same answer. The different counting method. If I use the same idea to continue with B, so I have 116 people minus the first table, I have 111. Okay, divide by the groups of 3. So I will have 37 groups of 3 plus the first table. That will also give me the answer 38. Okay, so this is about identifying a shortcut counting method. as also known as finding a formula to get you to be able to get to the pattern in a shortcut manner. Okay, so counting pattern. Right, okay, so this is the solution for question number 45, section C for revision paper, practice paper 2019. Thank you.